On your Cornell's notes, go ahead and write down potential and kinetic energy next to the topic. I'm going to go over the objectives for this lesson. You don't need to copy this. We will differentiate kinetic from potential energy, identify the factors affecting kinetic and potential energy. We will describe the three types of potential energy and identify the equations and SI units used for potential and kinetic. Go ahead and copy the whole diagram here. Energy is the ability to do work. So all forms of energy can be classified under potential and kinetic. For our study, we will not look into the other forms of kinetic energy, but we will discuss briefly gravitational, elastic, and chemical potential forms of energy. What is potential energy? Most people will say the potential energy is energy at rest. That is correct, because any object that is not moving has a stored energy ready to be used to perform a certain type of work. So the type of potential energy is what we call gravitational potential energy. Sometimes we just call this GPE in physics. So notice the illustration over here that an object that is lifted up from the ground has a stored energy now. It has the potential to perform work anytime the string is cut off and this object hits another object here on the ground. This potential energy will be changed into another form of energy while performing that work. So for our equation, you can solve for your gravitational potential energy by multiplying the mass of the object by the height of the object and by gravity. And remember that gravity or gravitational acceleration on Earth is equal to 9.8 meters per second squared. This boulder has a great gravitational potential energy. Even the dog doing his tricks walking on the rope has a gravitational potential energy. Now, based on the equation, we now have these three factors affecting gravitational potential energy. So mass, height, and the pull of gravity. Remember that the greater is the mass of the object, the more is its potential energy. An object lifted up higher will have a greater potential energy than the object in a lower height, and our gravitational acceleration in this case is simply constant. So every time we solve problems, remember that the G will not be given a value. You will have to memorize that, and by now I hope everybody memorized it. It's 9.8 meters per second squared. So from the equation mass times G times height, we came up with the SI unit for our GPE. Mass is in kilograms, gravitational acceleration is in meters per second squared, and our height is in meters. If you combine kilogram meter per second squared, you come up with a Newton. Multiply that by the meters, that will be in joules. Capital J or joules will be the unit that we will use when we're solving problems for energy. So in the illustration here, again, gives you the visual that a smaller object compared to a larger object will have a lower potential energy. So if the mass is doubled, 1 to 2 kilograms, the potential energy is also doubled, 20 to 40. And for the same mass, if it is lifted up higher, 1 meter versus 2 meters, for the same mass, our potential energy is also increased, 10 to 20 and 20 to 40. So the higher is the object, the more gravitational potential energy. The heavier is the object, the more gravitational potential energy. Again, gravitational acceleration is not included because it is constant, 9.8 meters second squared. Okay, so the second type of potential energy is called elastic. Of course, this is due to the compression and expansion of the object. A good example will be rubber band. The more you stretch it, the greater is its elastic potential energy. The same with a spring or a string. The third type of potential energy is called chemical. A coal, for example, can transform into light energy due to the chemical bonds within it. Another example would be the battery. Battery can be changed into light or sound energy. Even the food that we eat can be stored in our body in the form of chemical potential energy, and we use it to perform with the energy. Alright, now what is kinetic energy? This is energy in motion. So all moving objects will have kinetic energy. And any moving object, of course, has speed. So there are two factors affecting our kinetic energy here, the mass and the speed of the object. If we write the equation in symbol form, we came up with this: KE equals 1/2 mv squared, or you can just multiply mass times the square of v and divide the product by 2. Again, the greater is the mass, the more kinetic energy. The faster is the object, the higher is the kinetic energy. This unit of measurement for kinetic energy is still the same as PE, which is joules. So I gave you the breakdown here on how we came up with Newton's meter. The mass is in kilogram. The speed is in meter per second, but because we have to square it, then you came up with meter squared over second squared. If we simplify that, we will get kilogram meter per second squared, which is a Newton, times the meter will give us again the joules. So that's it. I hope that you've copied everything. Make sure you complete your notes and you turn them in, getting ready for your problem solving practice in the classroom.